Hey everyone, thank you for joining us. We are live with the May edition of the Azure Functions Community uh, Stand-Up. I'm Thiago Almeida. I'm a PM on the Azure Functions team, and I'm joined by Lily, who's also my teammate. And Lily, can you introduce yourself?
Hi everyone, my name is Lily. I'm a PM on the Azure Functions team.
Great. All right. So I wanted to cover some updates since the last meeting that we had, that was in March. And you can check out our newsletter, the May edition of the newsletter that just went out yesterday for the links for all of these. But just to cover some areas here, in the area of scale and performance, which is something that I've been working on quite a lot recently for Azure Functions, we released target-based scaling, which allows you to take more control of how the scaling works for your applications and your Azure functions. So make sure to check that out. On the languages, of course, this is the topic for today that Lily's going to take us through. But we have a new Node.js programming model, the preview for it, and we're going to cover that in detail in this session. On the topic of triggers and bindings, we've added support for all languages to the preview of Azure SQL trigger. And we also released a preview of the Azure Cache for Redis trigger as well. So make sure to check those out. On the topic of integrations, the API management team released API management authorizations, which is a great solution to ensure that you can keep track of the auth, and it will keep the connections live there, or the auth itself refreshed. And it's very good integration with Azure Functions. There's a blog post and links to the sample in the documentation for it as to how you can take advantage of API management authorizations together with Azure Functions to then connect to downstream solutions like GitHub and Teams and everything else. And then finally, on the topic of durable functions, we've announced the support for managed identity for the Azure storage part of durable functions, which is pretty cool. So again, check out our newsletter over there, aka.ms/functions newsletter May 2023. And that has all those links, and also has a link to this webcast if you're checking this out after the fact. All right. So with that, let me pass it on to Lily to take over from me and take us through the new Node programming model. Off to you, Lily.
All right, thanks, Thiago. So let's jump right into it. So we started the effort to create this V4 programming model because we had gotten feedback from user study and also from our community about the various aspects of the current experience that could be improved when writing function apps in Node.js. So the main objective of the V4 model was to create a more intuitive and idiomatic experience for JavaScript and TypeScript developers developing with Azure Functions. The design today is a culmination of feedback from the community, from surveys, user studies, and internal Node.js experts working with customers. There are various improvements made in the new model, and I'll be highlighting a few of them in this presentation. The model is in preview now. We are looking for feedback to further improve the GA experience, and you can be part of this by trying it out and leaving us feedback in our GitHub repo. Before I kind of jump into the next slides, I do want to mention that there are some version requirements for this new model. And so if you're trying it out, be sure that you're on the right version. All right, the first thing I'd like to talk about is the file structure. So if you are a current user of Azure Functions, the file structure shown on the screen should be very familiar to you. Basically, for every function, you would need to have a corresponding directory. And inside of that, you need an index.js file and a function.json file. And every time you add a new function, you would add a new folder to it. Whereas in the V4 model, we are making the structure much more flexible. You can really structure your function in any way you want. You could have all of your functions in one script, or you can have one function per script and then have all of your scripts under a directory. So I'm showing on the screen here an example of a possible structure, but it's really based on kind of your needs and whatever is easiest for you. All right, the next thing is in the v4 model, we've changed the way you configure triggers and bindings. So basically right now you would define your function in code. So on the left in the v3 model, we have an HTTP trigger, and it takes requests, it takes get and post requests, and you basically specify that in your function.json file. Whereas in the v4 model, all of that is done through code. So first, to register the HTTP trigger, you would need to get the apt object from the Azure Functions library. And then with that, you can do app.http and then kind of specify what you would in function.json as different properties now in the v4 model. So you can, as you can see here, the method is get and post that this trigger supports. And you might notice that the auth level is not listed here. And with the v4 model, if you don't have certain properties specified, we would help you default to a certain value. So in this case, since auth level is not specified, the default is anonymous. And we have added IntelliSense support, which I'll get into later, to kind of help you figure out what the values are expected for each property, and if you don't specify them, what the default would be. And I'll demo that later in demo time. So with the v4 model, everything again is specified in code. You don't need your function.json. And you might also notice that this looks similar to popular models like popular frameworks like Express. And that's kind of the idea here. We really want to make it so that the experience is familiar to JavaScript and TypeScript developers. And here is another example of an HTTP trigger, but with a little bit of a twist. We're adding an extra output here. In this case, when the HTTP trigger triggers, it will process a request and then send the request body to a storage queue. And so that's why you see in index.js, you have this extra queue output in the return. And then also in the function.json, we have the third section there specifying kind of the output as queue output, and it will send, in this case, the name to a queue called hello world queue. In the v4 model, you would do the same, but create this queue output object from this output object from Azure Functions. So I've created a queue output here, and I pass that in as part of the list that the extra outputs property is expecting. And then once I get the name from the request body, I am using the context.extraOutputs.set method to say that, okay, I want to send this name to my queue. So again, there's no need for the function.json. And if you need more outputs, you can obviously add in more because the extra outputs is expecting a list. So with this way of writing the code, it's much more flexible. And also, if you want to reuse your output, you could say if you have another trigger that might need this output, you could just reuse this queue output. I will demo this later in the demo. And the last example is a client function for durable functions. So the client function is the function that will start your durable functions orchestration. And in this case, we are using an HTTP trigger to start the orchestration. And that's why in the function.json file, you see type is HTTP trigger. And then also kind of the last section, you see that we're specifying as an input type orchestration client. In the v4 model, you do this by, well, first importing the df module from the durable functions library, and then passing the durable client as part of the extra input property of the HTTP trigger. And with that, you can get the client, the durable client from get client, and start the orchestration that way. Next, we've added new HTTP types that are modeled after the fetch standard in the v4 model. We're using a library called Undici, which will be part of the Node.js core soon. And we've made similar changes for both HTTP request and HTTP response. In this case, I'm just showing request here. And next up is IntelliSense, as I had mentioned earlier. So for the v3 model, only TypeScript has IntelliSense, but for v4, we've added IntelliSense for JavaScript as well. And so as you can see from this screenshot, if you do app dot, you see all of the available methods that you can use, what they do, what parameters they're expecting, what they return, etc. We'll kind of see this more in the demo later when I show the code. And for the v4 model, all of the triggers and bindings supported by Azure Functions are supported from a technical perspective. This means if you want to use them, you can use them right now. It's just that some of them don't have a convenience layer yet. So you wouldn't be able to register them like the way I had shown before for HTTP triggers. And then there's also no IntelliSense for these triggers that don't have convenience layer yet. If you need one that is missing the convenience layer right now, you can let us know in our GitHub repo and we'll prioritize that. Otherwise, if you need one right now, what you could do is to leverage the generic method, like shown in the slide here. So imagine if HTTP trigger didn't have the convenience layer today, this would be how you would set this up using the generic method. And it's very similar to kind of how you would write your function.json file in the v3 model. All right, now what is not changed? So in the v4 model, support for durable functions, including durable entities, is there. And for tooling experience, you can create your function project, your function templates on VS Code the same way you would in the v3 model. Or if you want to use the function CLI to do that, it's the same thing as well. And if you want to run and test your functions on Azure Portal, that works in the v4 model as well. The only thing that is not supported right now is editing. So for on Portal, you can't edit your functions if you've written them using the v4 model for right now. And you can expect writing logs and general troubleshooting to be the same. And if you use ARM and Bicep, you can expect to use the same properties in v4. And obviously, the same triggers and binding types are supported in v4 as in v3, and the properties stay the same as well. And there are no changes to how you would build or deploy your app, and obviously no changes in performance as well. So these are kind of all the things that have remained the same in the v4 model. I think that is it for kind of the presentation part. I will now move on to the demo. All right. Okay. And okay, it's showing only v3. I wanted to show v4 as well. Sorry, let me. V4. Okay, so my original intention was to show kind of v4 and v3 side by side, but it looks like I can't. So I'm just going to kind of show the v4 app that I have. So this app is relatively simple. It has two functions. One is an HTTP function. What it does is it will take the body of the request and upload it to blob storage. And then the other function is a durable function, which will back up all of the files in a directory specified by the user to blob storage as well. And in the v4 model, I can have all of that in kind of just two files here. So these are all of my durable functions related functions, and this one is my HTTP function. Whereas in the v3 model, each one of these would have to be in its own directory and also have like a corresponding function.json file. And so the structure there again is very inflexible, whereas here I'm just putting all of my functions under the functions directory. And then I have my output.js file. So here's where I have my blob output, and I will be using this in both the HTTP trigger and also in the durable functions trigger. So now let me go through the code for the HTTP trigger. So again, for lines 5 to 8, this would, in the v3 model, this would live in function.json file. Now we have all of that in code. And then we also have, again, the IntelliSense that I mentioned before that will kind of help you figure out what values are needed for each of the values. And if you don't have them, what the defaults are. And so basically what my HTTP function does here is it just gets the content, which is the body of the request, and then send it over to blob storage. Because of time, I've already deployed this app to Azure, so I'm just going to demo what will happen when we trigger the HTTP function. So yeah, if you notice, this is kind of the route that I specified here. And then the backup path is, this will be the name of the blob that will store kind of the content from lines 4 to 7. I'm going to send the request. Okay, so it's 200 OK. That means it should be good. So now I'm going to look at Azure Storage. So now in Azure Storage, I should be able to see kind of what I've uploaded. So if I download this, we see it. Sorry, it seems like I can't just share the whole. Maybe I can share the entire screen, so then I don't have to switch back and forth. Okay. Wait, can we see? No. All right.
Yes,
Okay.
we could see it before, Lily.
You could see it before. Yeah.
Yeah.
Okay. Yeah. So yeah, so this was what was downloaded from blob storage. I don't know if I was able to show kind of the blob storage cart.
Yes, we saw it.
Okay. All right. The next one is the durable functions. The durable functions orchestration. So for durable functions, you would have to first import the DF module from the durable functions package. I also have a bunch of other things that I need here, and the apt object from Azure Functions, as well as the blob output that I'll be using again. So if you want to register any durable functions related functions, you would have to do df.app. In this case, I'm registering an orchestration. And what this orchestration does is it gets the the root directory that you want to upload, that you want to back up your files. And what it does is it causes activity function to get all of the files in that root directory. And for each of the file, it does some modifying of the path, but then the core part is it calls this copy file to blob activity function, activity function to upload the file into blob storage. And once all of that is done, it will do some aggregation. In this case, I'm just simply adding up all of the bytes of the files. But obviously, you could do something more sophisticated. So here's the kind of the activity function to get all of the files in a directory. It's all it does is it looks through the directory and adds all of the files into this all files path list and returning the list. And then for this kind of copy to blob activity function, because we have to send the files to blob storage, we have this extra output, blob output. And in the callback, what we do is we're just using the stat method to kind of get the size of the file and then get the content of the file. And using this method, context.extraOutputs.set, to send the file to blob storage. And then just returning the size since that's what we're aggregating in the end. And to start your orchestration, I have an HTTP trigger here. Again, we need to have this durable client as part of the extra outputs. And once we have that in the callback, we can get this durable client to help us start this orchestration. And then obviously we're passing in kind of the path that we want to back up all of our files from. And I'm just logging the instance ID here because that's something helpful for us to track the orchestration progress. And then I'm just returning the status response. And we can also see what will happen if we trigger the HTTP function. So what I've done is I've created like a dummy directory here named files, and it has a subdirectory and a plain text file. Inside the subdirectory, I also have another text file. So I'm expecting once I send this request that all of the files here will be backed up into blob storage. So looks like it's been accepted. So I believe that is that's uploaded to blob storage. And it looks like I have to do another kind of stop sharing and reshare to kind of show that. So we have this from before, and then now we should have new folders under backup. So yes, so we have the text file and also this subdirectory, which also has another text file. So that's kind of the end of the demo. And I want to show the slide about with the references again, just so, yep. So You can find the developer guide that will talk more about the new model, much more than what I've covered today in the article. So please check it out. And then if you have a V3 model and you want to use the V4 one, we've also created upgrade guides to help you do that. And then again, check out our GitHub repo to see all of the in-progress work that we have. We are working on adding, for example, support for hooks and also adding support for the SQL trigger, as well as other things that we're working on. So you can check it out there. And then, like I said, the demo is out on GitHub, so you can check it out if you want to. Thiago, that's all from my side.
All right, thank you so much, Lily. I know we have one slide for Q&A. We had one question on the stream of when the V4 release will GA. And there was already a reply there mentioning summer. That's the Northern Hemisphere summer. If you're watching this from the Southern Hemisphere, I guess it would be winter for them. But we'd love some feedback if they get a chance to try this out before we GA. And the rest of it was a lot of good praise for the updates. I think I was thinking just before, one of the key areas for Azure Functions that we want to focus on is developer productivity, and these updates to the Node.js programming model definitely fit into that quite a lot. So I hope everybody enjoys it and look forward to seeing this being used more and more. With that, I think just wanted to thank Lily for presenting to us and putting together the demo as well that people can now go and check out. And we'll see you next month in June. We're going to do another one of these. We'll probably be talking about a summary of everything related to Azure Functions during the build time frame after the build conference happens. So I think that's it for now. Thanks, everybody. See you next month.
Thanks, everyone. Bye-bye.